Okay, in this lesson, we shall be doing a couple of things that are very interesting. But first things first, we shall spend time on this question on Euclidean geometry, right? O is the center of the circle and diameter KL is produced. Okay, there's a diameter KL that passes through the center O and is produced. So it is extended to meet NM at the point P. Okay, so we can see the point P there. Now, the line segment ON is parallel to LM. So you have the line segment ON. Okay, so you have the line segment ON here, and it is most certainly parallel to LM. And the angle F is actually 76 degrees, and we're able to see the angle of 76 degrees there. Now, calculate giving reasons the sizes of. We're looking for the size of the angle L1. What is the size of the angle L1? Right, where's an idea? What do you think the angle L1 is? Tando, what do you think? What do you think the size of the angle L1 is? Do you have an idea? Any idea? Yeah. Senulo, what do you think?
76 degrees.
It is exactly 76 degrees. So the size of the angle L1 is 76 degrees. Why is the angle L1 76 degrees, Tando? Angles in the same segment. Angles in same sag. Okay, these are angles same segment because we are able to see this here, this shape. Simultaneously, we can see this shape here, and therefore in mathematics, an angle that is here is equal to the angle that is there. So we can say therefore that angle L1 is equal to 76 degrees. So we know that the angle L1 here equals 76 degrees. Okay, right, we move on to the next question. And we attempt the next question. Let us move on to the next question. What is the next question? The next question is the size of the angle O1. Right, this angle here. Who can tell us what the angle O1 is? Because we already know this one is 76 degrees. What is the size of the angle O1? Anyone? Senulo, what do you think the size of the angle O1 is? This is the angle O1. What is the size of the angle O1? Anyone?
It is 154.
Why do you think it's 154?
152, sorry, 152.
Why? Why? Well, what do you think the reason is for that?
Angles at the center are 2 times the angles at circumference.
Which one is the angle at circumference? Because now, if you have a shape like this, and you can have this, so the angle at center is twice an angle at circumference, or you can have something like this, and you have something like this. Okay, let me draw something bigger here. Okay, you have a center here, and this is an angle at center, and then now you can have this. So this angle here at center is twice that angle there. Right, so which one? Which one? So, yeah, do not speak in parables. Speak clearly. What angle is equal to the angle of 1? And we are saying it is equal to that size. Why? It's 2 times which one? It's 2 times which one, Tando?
L1.
It's 2 times L1. Okay, it looks that way. Yeah, but it's a little bit tricky. It's a little bit tricky. Because what you can see is that you have been told that KL is the diameter. KL is a what? Diameter KL. So in other words, this one is a straight line. And then this one here this one is parallel to this one. So in mathematics, then if you have something like this, you have this, and this is parallel to this, and this is equal to 76 degrees. What is this angle here and why? What?
76 corresponding angles.
Yes, it is 76 degrees, and these are corresponding angles. Well done. That's cellular, right? Right,
Yes, sir.
corresponding angles, well done. Right, they are corresponding angles, so it is clearly actually 76 degrees there. I can see they've put it the center, but it doesn't actually always have to be angle at center, so I think at circumference. So corresponding angles, now tell the examiner which lines are parallel, and they're exactly these ones here. They're ON and M. Right, so you can see that the angle ON is parallel to the angle LM. Like so. So we found this angle here, which is actually exactly 76 degrees, the angle O1, but also we know that the angle L1 itself is actually an angle that is 76 degrees over there. Okay, next question. Let's see now. 4.3, we want to find the size of the angle M4. What is the size of the angle M4? Anyone? What do you think? What do you think? Right, want to find the size of the angle M4. We already know this one is 76 degrees, but obviously we already know that this angle here is also 76 degrees. And then what is the size of the angle M4? Who knows the size of the angle M4?
Isn't
Ayanda.
it 76 degrees, sir, also?
Why would you think that is the case? A very good idea, but why do you think that is the case? Would you think that is the case?
A bow tie, sir. I see a bow tie there.
Yeah, I get your point. A bow tie is obviously what appears to be the case. But now, obviously, what you can see that is something like this, and then there is something like this. All right, and then this one is resembling this kind of a formation in mathematics. If there's an angle at center,
Okay.
yeah. So now, if you know this one, this angle O1 is what? What is the size of the angle O1? It is actually 76 degrees.
76.
So what is the angle M4? Because it's like this. So see, this one here is always like this, but it can always be done differently. You can have it drawn as well this way. So
Oh,
yeah. So these
okay.
two are the same thing, but it's just that now this point is immovable. So you can move this point. If you move this point like this to the side, then it looks like this. And then if you move this, if you imagine this being a rope and a rope being moved like this, then it's going to look like this. Okay, now we can move this. If you move this, then it's going to be something like this, because you move it such that it stays on the boundary of the circle. So yeah, all right, but you already know that O1 is 76 degrees. So in other words, what is the relationship between M4 and O1? So you know that the angle O1, what do you think? Okay, now
Angle at center is 2 times angle at circumference.
Thank you so much. Angle at center is 2 times angle at circumference. So we know therefore that the angle O1 there is at, which is the angle O1 is 2 times this angle here. It is 2 times angle M4, and it is angle at center. Right, angle at center equals 2 times angle at what? It's circumference. Right, it's circumference. So what do we say now? Okay, moreover, what is then the size of the angle O1? It is 76 degrees we saw. Right, it is 76 degrees 2 times the angle M4. And therefore, the reason for this is that angle O1 is 74 degrees. Okay, at this point, you have 76, you divide by 2, and this is 2M4. You divide by 2, and what is the answer? What is 76 degrees divided by 2?
38.
It is 38 degrees. Thank you so much. Well done. Right, so that is the angle M4. So we can see that the angle M4 is actually 38 degrees there. And we saw that this one is 76 degrees L1. We saw that this one is also 76 degrees. Right, the next thing, we want to find the size of N1 and N2. N1 and N2, this one here. What is the size of N1 and N2? So now, as an important precautionary measure, we want to find this side, the size of this angle N1 and N2 there. Right, the question is, how do we then find the size of N1 and N2? as described there. Okay, and I'm sure that is very straightforward. Right, who has an idea on how we can find the size of N1? Because we already know that this one here is 76 degrees. And we've already seen that this one is also 76 degrees, the O1. We have already seen that the angle M4 is actually 38 degrees there. And it remains to actually then proceed to find the size of the angle N1 plus N2. I'm sure that somebody is thinking very carefully about it. And the question is, what is the size of this angle here? Right. Who has an idea on what the size of this angle is here? Anyone? Too easy. Who is asleep?
Okay, isn't it 90? Isn't it 90,
Okay.
sir?
Yeah, that's interesting. But obviously, see an angle that is 90. Yeah, that's an interesting point. Okay, if it is obtained by a diameter, we know that that angle becomes 90 degrees because we say it's an
Right angle.
yes, it's the right angle. So it becomes an angle in semicircle if it's obtained by a diameter. So obviously, see at this point, this one is the diameter is this one, and the angle N1, N2 is that one here. But now this is way too easy because we are smart and we know the theorems at grade 11. Okay, these theorems, guys, will carry you through grade 11. They are there in grade 12 as well. So now if you have a shape like this, an angle that is here is equal to an angle that is there. Okay, it can always be like this. An angle that is here is equal to an angle that is like there. Okay, so an angle that is here, we call this theorem, we say the exterior angle of cyclic quad. Right, because once you say the exterior angle of cyclic quad, we know it is equal to the interior opposite angle. The interior opposite angle sits like there. And if this is the exterior angle, the interior angle sits there. Okay, now what do we do here? Because this is way too easy for us. But this is not the only way to think about it. Right, there are a couple of other ways. But now we also know something. What do we know? We also know that if you have a shape like this, the opposite angles are what of a cyclic quad? What do you know about opposite angles of a cyclic quad? Opposite angles of cyclic quad are what? Opposite angles of cyclic quad are what? If this is cyclic quad, the opposite angles, when you add them up, what do you get? If you add them up, what do you get? Anyone? Too easy. Okay, if you have a cyclic quad, the angles when you add them, because here you have this, it goes to the circumference, and a quadrilateral has 4 vertices. So this angle plus this angle is 180 because they are opposite and they are angles of a cyclic quad. So in other words, we know therefore that the angle N1 plus the angle N2, you add to the opposite angle 76 degrees, and the result must be 100 and what? And 80 degrees. Why is it that this plus this is 180 degrees? Because of the opposite angles of cyclic quad. Okay, opposite angles of cyclic quad. Now, N1, angle N1 plus angle N2 is equal to what? Is equal to 180 degrees minus 76 degrees. Right, so that the angle N1 plus the angle N2, what is 180 degrees minus 76? What is the answer? What is the answer?
104.
104. 104, thank you so much. So we're getting 104 degrees, and this is the answer. So the angle N1 plus N2 is 104 degrees, and that is the answer. The rest we've already got. And then it remains to find the size of the angle M1. The size of the angle M1. Okay, too easy. Let us find the angle M1. Right, the next thing is to find the size of the angle M1. What is the size of the angle M1? M1 is exactly this one here. So how do we find the size of the angle M1? Remember that NM is produced at P, right? Or yeah, to meet NM produced at P. So this NM was produced here. So in other words, this one is a straight line, this. And also this is the diameter. KL is produced. So this diameter is produced. So if you extend this diameter, okay, the fact that it is produced, the examiner uses the word produced to actually mean that these are straight lines, because there are a couple of angles here like L1, L2. It might look as if this one is not straight, but the examiner gives me the guarantee that, hang on, these are produced and therefore they are straight lines, these. Okay, now the question then is, what is the size of the angle M1? This one here. The size of the angle M1. Who can find the size of the angle M1? Anyone? Okay, because you already know that this L1 is 76 degrees. L1 is 76 degrees. And then, if this one is 76 degrees, you've already found this one. And because it was forming something like this, with L1, we saw that this was also 76 degrees. The question is, what is the size of the angle N1? Rather, M1, M for mother. Right, so I want to find the size of the angle M1. Right, I'm sure that somebody can find this with so much ease. And one can think of the best way to actually find this angle here. As it stated here, this is way too easy to be determined. Right, it can be found with so much ease, because you already know the angle M4. What did we find the angle M4 to be? What was the angle M4? We found it to be 38 degrees. Right, we found the angle M4 to be 38 degrees. Right, so if the angle M4 is 38 degrees, then what is the size of the angle M1? Who wants to find the size of the angle M1? Is everybody thinking it's too easy? Is everybody thinking that it's a little bit hectic to find? And we therefore need to think very carefully on how we can find the size of the angle M1. Who is thinking about it and why? Right, please think about it, because we need to find the size of the angle M1. And M1 is this angle here. It is from here to there. Right. So the question is then, how do we find the size of this angle? Because this one you already know. Right. And if you already know that, there are a couple of other angles that you already know, as said M4, you know, and you already know, for instance, the angle O1, okay? And what else then do we need at this point? Because you know that N1 and N2, for example, you got N1 and N2. What did you get N1 and N2 to be? Like 104 degrees. So this one is 104 degrees. Right, this angle N1 and N2. And so, if this is the case, then what is the angle NM1? Right, who is reasoning? Who is thinking with us? Or who is not thinking with us? Or somebody is a little bit fast asleep? Okay, because obviously I'm sure that this is a very interesting question. But who is there and who is not there? Okay, any idea about M1 and why? Who has an idea about the angle M1 and why? Okay, I can see that some people are just a little bit quiet, and we are thinking, and the question is, who really can give us an idea of this particular answer over here, for example? Who really can give us an idea of that? Who can? Who can give us an idea? Right. Anyone? Is it Tsenulo? What do you think, Tsenulo? How do you think we can find the side of the angle M1, Tsenulo? What do you think? What do you think? Is it too easy or a little bit difficult to find, and why? Is it too easy or a little bit difficult to find, and why? Why is that the case? Or you are still thinking too much about it? Tando, are you able to see the diagram, or maybe the diagram is not clear to you guys? I'm interested in seeing who can think about it before I give you guys the answer to this question, but who can think about it? Who is able to think about this question very, very carefully? Right.
Sir, I am guessing, but I'm gonna say it's 76 alternate angles.
Okay, you're on point.
I
You're
was
on
just
point.
going to say the same.
You're gonna say the same thing. Is that Ayanda?
Yes, sir.
Okay, thanks, Ayanda. Thank you. Okay. Now, there are a couple of things that are very important, because in mathematics, if we have a circle like this, and we have, so you need to write down these theorems. Because now, if there is a diameter subtends an angle of how many degrees at circumference? Every diameter subtends an angle, makes an angle of 90 degrees, or it makes a right angle. So because this one is a diameter, KL is a diameter, KL, so it makes this angle is 90 degrees, this one. Okay, if this angle is 90 degrees here, we are good enough. We are so good, because this one is a straight line, this. So this one is already 38. This one is already 90. What must this one be? Because we must add this and this and this and to get 180 degrees, because this is a straight line, this. So in other words, angle M1 plus 90 degrees. Okay, so you need to write it step by step. Let's just first say, let's just tell the examiner why. So you can say M2 plus M3. M2 plus M3. This one, M2 plus M3, because it is like this type. Okay, so M2 plus M3 is 90 degrees. Why is that the case? Because it is an angle subtended by diameter. We say it is an angle in semicircle. So this is an angle in semicircle. Right, so that we then come and say angle M1 plus 90 degrees plus 38 degrees. Okay, so M1 plus 90 degrees, because this one is 90, plus the 38 degrees. Okay, we get adjacent angles on a straight line. And this is 180 degrees. And the reason is angles on a straight line. Right, so we have angle M1, which is 180 degrees minus 90 degrees minus 38 degrees, which is the angle M1 equals. What is the answer here?
52.
You're getting 52 degrees. Okay, that is
Yes,
the
sir.
point. Yes, definitely. That's brilliant. So yeah, it is 52 degrees there. All right. So it is exactly 52 degrees. So which means that this angle is 52 degrees. Okay. Some of these questions require you to reason. Some of them require you to think big. You don't need to think small, because you're going to see these questions both in grade 11 and also at matric. So they're there to get you, these examiners. They don't joke. They mean business. And now you must be wide awake. You must open your eyes, because if your eyes are closed, then you are in serious trouble. But it's very, very fascinating that we've been able to get that angle there. So the angle M2 is actually the angle M1, excuse this one here, Mr. Examiner found it. It is 52 degrees. Now we need to prove that KG equals GM. Right, here is K. And we actually look, G is this one. And M is this one. So you need to prove that KG equals GM. Let's take it here. So we need to prove that KG equals GM. This is K, G, and M. You need to prove that this KG equals GM. And it's way too easy. Let's see now. Now to prove this one, there are a couple of things that we can use. One of which, to prove if there's a center, it's to use a theorem that says that if you have a center of a circle and you have a perpendicular, okay, it doesn't have to be like this. If you have a circle with a center and you have a perpendicular line from through the center, then if this perpendicular line is this one here that is passing through the center of the circle, this theorem is clear that you must have that in the end, this perpendicular line bisects this chord. Okay, so if you have a perpendicular line, it bisects the chord. Okay, so what do you say here? Anyone? Anyone? Fast asleep? Okay, so to prove that KG, this is K, G, M. To prove that KG equals GM, we just have to note that something is very important for us to consider, and we need to note that we need to show that there is an angle of 90 degrees somewhere there. We must show that this angle is 90 degrees, but you already know that. Let's see the way there is a 90 degrees. So like this one, we already know it's 90 degrees because it's an angle subtended by a diameter. So in mathematics, if there is a diameter through the center, it subtends an angle of 90 degrees at the circumference of a circle. So yeah, if this is the case, can we be able to see something similar? Wow, this is like this. And it is also like this. What do you call these here? What do you call these? The angles that are like this. And then now this is parallel to this, and therefore this angle here must be because of this angle there. What do you call these angles here? Anyone? Anyone? All right. So this angle is in Z or in N, depending on what you call these, Z or in N, depending on the position.
Alternating angles.
Thank you so much. There are alternate angles there. There are alternate angles. Well done, Tando. Well done, Tando. So now we're able to then say NGM. Angle, NGM. Right. NGM. Say NGM. This angle here must be equal to this angle here, M2, M3, or you can call it KML is equal to, so in other words, this NGM is equal to KML. KML, and this is equal to 90 degrees. Why? Because these are alternate angles. But always, when you see the kinds of angles that are justified by parallel lines, always tell the examiner which lines are parallel. And these are the lines ON parallel to LM. So ON is parallel to LM, like this. ON is parallel to LM, like that. Okay, so that's what we have. So in other words, this angle is 90 degrees because of those angles there. So if this one is equal to this one. Okay, because they're equal because of the Z-like shape, alternate angles. Okay, so yeah. And therefore, if this one is 90 degrees now, and this one is a straight line. Okay, it's a straight line. Okay. Now, and this is 90 degrees. So also this one must be 90 degrees. Right. So in other words, now what we're having, and also you can say that this is 90 degrees. This. Oh, yeah. Alternatively, one can come and say that is 90 degrees, or you can say angle O2 is equal to angle O2 is equal to this angle KML is equal to angle KML, which is equal to 90 degrees. Why is O2 equal to this? Well, they're equal because, or you can take O3. It's better to take O3 because this is a straight line, this. And you have this, yeah. So you can take O3. Okay, so O3 is equal to M, and this is the same thing because what you're seeing is you have something like this, and you have something like this, and then this angle here must be equal to this angle here. Why? What are those angles? These are the what? These are the corresponding angles as well. Right, they are corresponding angles. Why are they corresponding? They are corresponding because ON. All right, I'm trying to strengthen your geometric understanding this week. ON is parallel to LM, but yeah, but there are many other things we're gonna do. Similarity and proportionality for the matrix is also the kinds of questions we're gonna do. So this O3 is and this. So now that's O3. Angle O3 is equal to angle O2 equals 90 degrees. And these are both 90 in this case because they are adjacent angles on straight line. Okay, so yeah. Now, we're excited. When this is the case, when you have perpendicular line through the center, it is a bisector, so it means therefore that it follows that OG is perpendicular to, it follows that OG is perpendicular to the other one. Right. OG, this one is perpendicular to KM. Okay. Now, if it is perpendicular to AM, then this means, therefore, at this point, that KG, which is this one, KG equals GM. KG equals GM. Why is KG equals GM? KG equals GM because perpendicular, or you can say perpendicular from center to chord, yeah? Perpendicular from center to chord. Right, perpendicular from center to chord. Perpendicular from center. There's a perpendicular from center to chord. This perpendicular is from center to chord bisects the chord, and this is the result. Right, now this sounds like, hey, excellent news. Okay, this lesson is recorded, so you have a chance to play back and to make sure that you enjoy the goodness of listening to the video and the lesson recording. And we shall be doing lessons more often this time around moving forward. At least a couple of days, 3 times a week or so, we shall be online to make sure that we sharpen your skills. Let's look at the next question. Here's the next question. Right, AB is the diameter. Here is A, and here is B, and this is the diameter of the circle. What angle does it subtend? What is the size of this before they even ask us anything? What is the size of this? Why? So you see, if you have a diameter subtends an angle of how many degrees at the circumference? Of 90. So this angle must be 90 degrees. It's an angle in semicircle. They did not tell us, but because the diameter, then we know. Okay, the chord ED, and now there's chord ED and diameter AB. Right, there's a chord ED and diameter AB are produced to meet at C. So chord ED and diameter AB are produced to meet at C. Write down the size of D4. Give a reason for your answer. You see, they said write down the size of D4. What is the size of D4? What do you think the size of D4 is? Anyone? Anyone? Hello? Anyone home? Anybody home? What do you think the size of D4 is? What do you think the size of D4 is?
90, sir.
90 degrees. Well done, Tsenulo. Why, Tsenulo? What is the reason? D4 is 90 degrees. I concur with you. But why? Because it is an angle in semicircle.
Angle subtended by diameter.
Angle subtended by diameter. Yes. Angle in semicircle, or you say angle subtended by diameter. Okay, because an angle subtended by diameter is always a right angle. Okay, if you have a circle like this and there's a diameter, it must always subtend. If it subtends, if someone tells us diameter, meaning it passes through the center, it must subtend an angle of what? Of 90 degrees at the circumference of a circle. Let us continue to do 5.2 right now. 5.2 is this one. We already know D4. If A1 is 22 degrees, A1 is this one, is 22 degrees. Angle C is 24. Calculate the size of D5, this one, and deduce that DA bisects BAE. DA. Okay, first we must calculate the size of D5. D5 is this one. Right, we want to find the size of D5. Right, so anyone? Right. Anyone want to find the size of the angle D5? Okay, right. I know that you guys are very smart. You really are very smart. Because you are very smart, you can tell me the size of D5. So yeah, I'm all ears. I'm all ears. What do you think the size of D5 is and why? Anybody? Hey, this is geometry. Guys, you must think from grade 10. You must think from grade 10 and then bring metric. Huh? Bring metric. We need D5. And D5 is obvious. It is watching you. It is screaming at you. It is screaming at your face. What is D5? Please, anyone? What is it? D5. D5. Yes, D5. Tando, what do you think? Maybe the diagram is not clear. Is it not clear, this diagram?
Say,
It
I
is.
know that D5 is an exterior angle.
You know that, well done. D5 is an exterior angle. I agree with Tando. And now, if you have an exterior angle of a cyclic quad and it's a quadrilateral like this, quadrilateral means that you are dealing with a four-sided shape, and this angle must be called an angle there. So what is D5? Because now you see the challenge is this D5 would be equal to the whole thing here. But we don't know this one, right? So if we knew A2, then we could say D5 is all this, and then we could just find the sum of this. But we don't know A2. So what do we do now? What do we do? Ayanda, what do you think? I'm trying to get you guys to learn how to reason in geometry. What do you think, Ayanda? What do we do? What do we do? Okay, we go back to grade 10. We go back to grade 10. And we say, when we were smaller than these, the teachers at grade 10 taught us something awesome. And the teachers said the following, right? They said that the exterior angle of a triangle is equal to the sum of the interior opposite. The teacher said if this one is A, this one is B, and this one is C1 and 2, the teacher said angle C2 must be equal to angle A plus angle B, and these are exterior, or the exterior angle of triangle equals the sum of the interior opposite angles, like this. Okay, so this is what we say. Now, it means that the angle D3, okay, because chord ED is a chord, and diameter AB is the diameter, are produced to meet at C. The fact that they are produced, it means that these things are extended as straight lines, and this is extended as a straight line. So this one is a straight line. So we have the kind of triangle that is doing these. Okay, the examiners are a little bit clever. You have the kind of triangle that is doing this. Okay, trying to draw that shape there. Okay, so as I'm trying to draw that shape there, we have the following. Right, so we have this with that. And this angle must be the sum of these two. Right, so it means therefore that we are able to say angle D3. Right, we're able to say that angle D3 is equal to the sum of those interior opposite angles. So we're able to say that angle D3, this one here, is equal to 22 degrees plus 24 degrees. This D3 is equal to this one plus this one, you know, because it's like sitting outside there. And this is the kind of triangle you're getting. This is the kind of triangle we have, and this is it. So this D3 is equal to 22 plus 24. Why? Because it is an exterior angle of triangle equals the sum of interior opposite angles. So what is angle D3, folks? It is exactly 46 degrees. Okay, so we're able to see therefore that this angle here is actually 46 degrees. This angle is 46 degrees, this one here. If it is 46 degrees, then what is the angle D5? Because now this one plus this one must give us 180. So what must this D5 be? So which means therefore that the angle D5 plus 90 plus 46 degrees is equal to 180 degrees. Why?
Angles on a straight line.
Well done. Angles on a straight line. Angles on a straight line. So at this point, because of that, then we're able to see that the angle D5 is equal to 180 degrees. Then we move the 90, we move the 46 degrees. We move the 90, move the 46 degrees, which means the angle D5 is, what is 180 minus 90 minus 46? What is the answer? 180 minus 90 minus 46. What are we getting? We're getting 46.
44, sorry, sir, 44.
Oh, okay, you're thinking it's 44. Yeah, I'm trying to obviously have it cross-checked to make sure we avoid mistakes. So we have 180 and we minus 90 and we minus 46. I'm trying to check with my calculator to make sure that, well done, it's 44 degrees. Okay, So in other words, we had to, you see, this question was saying, calculate the size of D5. So we can see clearly the angle D5, as Tando was saying, and thanks for the answer, Tando, it is 44 degrees. Okay, now, if this is the case, they said calculate the size of D5 and deduce that DA, like the Democratic Alliance, okay, in politics in South Africa, DA bisects BAE, right? So in other words, DA bisects BAE. So yeah, want to prove that DA is this one, bisects BAE. So we must just, to prove that this DA, this is D and that is A. To bisect is to divide into two equal parts, right? So we just need to establish the fact that this angle is equal to this. Okay, we need to show that A1 is equal to A2. But you already know that A1 is how many degrees? It's 22 degrees. So it remains to just show that A2 is also how many degrees? It's also 22 degrees. Just have to show that A2 is also 22 degrees. So how do we show this one here? That A2 is also 22 degrees. Right, so you need to think about it. You need to show that A1 and A2, because they're saying deduce that DA bisects BAE. So to prove that DA bisects BAE, we need to show that A1 and A2 are equal. Then it means that this angle is bisected. To bisect the angle is to divide it into two equal angles. So the question is, we must show that. Then how do we show that this angle is equal to this? Because this one you already know is 22 degrees. How do we know A1 is 22 degrees? They gave us, they said if A1 is 22 degrees, so we know it's 22 degrees. We must just show that this one, A2, is also 22 degrees. So how do we show that A2 is 22 degrees? Anyone home? Anybody home? Neo, what do you think, Neo? Hello, Neo. Yes, Neo. What do you think the answer is, Neo? Are you asleep, Neo? Neo is quiet. Okay, there's a student called Neo. But I know Neo is quiet. Neo is a little bit quiet. Okay, let's see. Okay, yeah, Neo joined, I think, and left again. Okay, that's fine. Because he's new, he's still learning these things. Yeah, but yeah, we'll see what to discuss with Neo. All right, now we must just show that A2 is actually 22 degrees. So, anyone home? This one is too easy. Because you already know that the exterior angle, right? Okay, I know that you know the exterior angles very well, you guys. So this one here is equal to this one. So in other words, the angle D5, which is 44 degrees, is this one, D5, which is 44 degrees, is equal to this. It's equal to 22 degrees plus A2. So it's like the exterior angle. Okay, because this shape here and this shape here that does this. So in other words, you have the exterior angle of cyclic quad equals the interior opposite angle. Okay, so if we have 44 degrees, which is equal to 22 plus A2, what do we say is the answer? So this is like 44 degrees minus 22. We transpose the 22 across, and this is the angle A2. So what is the angle A2 now? Which means the angle A2 is equal to the angle A2 is equal to 44 minus 22 is clearly how many degrees? 22 degrees. This has proven that this one is 22 degrees. So this one is 22 and that is 22. And the conclusion that is that, so we come here, we then say, therefore, angle A1 is equal to angle A2, which is equal to 22 degrees. Right. So, and because this angle is equal to this angle, it therefore means that, therefore this means that DA bisects BAE. DA bisects BAE. So this DA here bisects BAE. Right. Okay, that's awesome. It was an interesting discussion we had on solving this particular question. Let me check the next question. Complete the following by writing the appropriate missing word. If a chord of a circle subtends a right angle on the circumference, then this chord is a what? Okay, we've been discussing this so many times. There's a chord that subtends an angle that subtends a right angle. What do you call the chord that subtends a right angle? So in other words, we have a chord like this that subtends a right angle at the circumference. What do you call this chord here? This is the chord. What do you call that chord that subtends a right angle at circumference? What do you call it?
Diameter, sir.
It's the diameter. Well done. Thanks, Tenulo. It's the diameter. I'm happy that you guys are wide awake this evening. Right. This one here, I'm going to call it your homework. I'm not going to be long today, so we shall be meeting a couple of times a week, like 3 to 4 times. 3 to 4 times, yeah. But yeah, if you're busy, you let us know, you communicate that you're busy. This one is your home activity. This one is your home activity. Is your home activity? Let me see. Okay, it's the last question. So this one is your home activity. So please, please, guys, do this home activity because we shall discuss it. Okay, so we meet today, and then the next day we take a break. Because we met today, and today is what day? It's Tuesday. It means that on Wednesday we're not going to meet because you need to breathe. I'm going to meet other students on Wednesday. I'm going to be doing mathematical literacy with those who are doing mathematical literacy. So we take a break, and then we don't meet on Wednesday. Then we're going to meet on Thursday. Okay, because you need to breathe. I want you to do other subjects as well. I don't want you to only learn mathematics. You see, it's not fair if I just say come every day. That's when I'm going to do other homework. So I must give you time to do that. But obviously, yeah, it was awesome meeting you today. And thanks so much, guys, for joining us. This is your homework. I'm going to post this video in the next couple of minutes so you can watch the video and then try this home activity. Okay. Otherwise, thank you guys for joining us. I'll see you again on Thursday at 8 p.m. For those who are free during the day, we can meet at 4, but I know most of you guys are still at school at 4, so we meet at 8. Yeah, thank you guys and have a good evening. And goodbye and have a good night. Okay, goodbye. Goodbye. Goodbye.